All right, it's the 8th of April, 2025. This is Aiken PBL live coding. We have been on an adventure. We've done some testing. We looked at some basic validators and started from the perspective of how to write integrated tests in Aiken. And hopefully people have learned a lot about the different data structures that you use when you're building a Cardano application. And we've had a guest lecture series. I mean, Hinson's been a core lecturer in this course from the beginning, but has prepared a couple of specialized lectures. Gave us one a couple of weeks ago. Then we had Lawrence last week showing us how to use Yahtzee in a local dev environment. So that was cool. And so now we're going to zoom even a step further out, back from the code directly and into a place of really thinking about how you draw up the designs for an application before you get going. I know a lot of people, we got Emmanuel and Harsha here. You guys have been working on Asteria, and we've been talking about how different endpoints get used. How do you describe the endpoints of a set of validators? So Hinson drew up some notes and an example app that we're not so much going to be writing code for today, but really thinking about its design first. Am I saying that right? Hinson, we're drawing pictures today, right? Or where you at? I don't know if he has sound. Can you hear us? No. Hey, Newman. Hinson.
Hey, hey, can you hear me?
Yeah, we got you. Can you hear me?
Yeah, good
Okay.
for now. So I could start from here, right?
Yeah, yeah. So we're gonna look at like the design of an application.
Yep. Then I jump straight to the code examples. So for today's lecture or lessons, we'll cover the module 301, which is more about how to architect your applications. So here, if you go to the Aiken PBL student example library, I've written down a set of Markdown files to go through. Typically, what are the steps that we have to think about, like at the time that when we want to build up some actual Cardano projects and design the scripts. So here, there's a introductions. So what we cover here, what we're going to cover here is that we try to use the Plutus NFT example in the mesh open source contract repositories to walk through step by step about when we, let's say, for example, want to design an application like that, what should we think about and what are the steps and what actually we have to kind of design before we're actually writing any single line of code. So usually this process I will describe is the most difficult part, but this is not the part of writing Aiken code. It's actually the design and the architecture itself can tell someone is a more of a senior Cardano engineer than a junior. So so this is a background. So about the um, table of content of today is that first of all, I will cover a little bit what's this set of contrasts doing and what is the aim of it and what are the expected outcome of having a Plutus NFT project. And then I will try to cover every single step by step. So after that, I will try to walk through what is a program dependency tree, and then goes into how can we write a contract specifications, in particular, a minting one and also a spending one. And after having the specification, I will walk through. Usually, we would like to produce something called user action documentations, like what exactly the users can do with your dApps. And then at the end of the day, like a lot of different Cardano application, there are necessary setup procedures. So usually we also have to write up something for about it. And I'll also walk through a little bit on how you usually prepare these sets of documentations. So usually when we try to build a serious Cardano dApp, we will go through all of these steps before writing any single lines of code. So without further ado, let me directly jump straight to the first part of today, which is explaining a bit about the background of the contrast that we are writing or using as an example. So when we go into the mesh core repository, navigate into the Plutus NFT, we can find the project itself. So Plutus NFT contract is indeed serving a very, very simple purpose. Is that if you know about a little bit of the history of Cardano, prior to the Alonso era, we don't have any actual NFTs. So for a lot of different NFT projects out there, they're in the very, very early days, they're like using a native scripts to have a pseudo NFT. What does it mean by pseudo NFT is that for the Mary era native script, you could define two parameters about guarding the minting or burning. First is about which key control the minting or burning right. And then the second is that is there a time lock? Like it could be only valid after a certain time period or only valid before a certain time period. So in the early part of the Cardano history is that there are a lot of projects just control the minting by the private key on the back end, like including the very famous Hotkey NFT is the same in the early days. Like they will have a time lock about the NFT policy, like for example, 1 year or 2 years or a few months from now, and then just before this deadline, the project could freely mint different tokens with different token names. And then in the backend, they will try to avoid the naming collisions, such that the NFT minted, there's a only single unique access name out there. And once after time law has been processed, they will be permanently unique. So there's kind of the history of how Cardano projects do the NFT in the early days. However, since the Plutus contract has been introduced, there are actually a mathematically valid way to allow us to prevent some token names from being duplicated. Because when we talk about the definition of non-fungible tokens or NFT in Cardano is that for the unique combination of policy ID and token name, there only exists exactly one as a quantity out there. So this Plutus NFT contract is indeed a demonstration about how we could perform this kind of checking on chain, like having the on-chain validation about preventing the token name collision under the same policies. So perhaps there's a little bit abstract. Any questions from the floor? And yeah, before I move on into what exactly this contract do this thing.
You did a really good job framing. Like it's amazing that we ever had quote unquote NFTs without this. It's wild to think.
Yep. So let me just jump straight into how this scripts can do or yeah. So but when we take a look into the kind of the overview about the contract, there's actually consists of three different scripts. When we have a little bit of the spoiler, there's a Oracle NFT and there's a Oracle and then there's a Plutus NFT. So let's come back to here to take a look. Yep. So now we know that we want to we want to having a smart contrast, a set of smart contrasts or validators that could help us to get through that a single policy having not duplicated token names. So in this set of example, we could just firstly think about the entire objective of this set of validator of this Cardano dApps is to create a Plutus NFT, which is not actually having the duplicated token names. So we think about from that perspective is that at the end of the day, this Plutus NFT is our product. And then we want everyone, whoever tried to mint this Plutus NFT, have to refer to something like the single source of truth. Like I want to kind of preventing anyone from minting about this. So we have a very simple kind of beginner level of computer science kind of concepts about how we could do it. Is that for whenever there is a person minting an NFT, the count will be +1. And then for whatever people try to mint it, they have to add the count by 1. And then we have to also making sure that this count is encoded into the token name. So that for whoever tried to mint, they're actually just by the same time adding 1 into the count, and then they have the previous count engraved into the token name. So this is core logics of the applications. And then we have to think about the first thing usually we have to think about is that if there is any kind of parameter dependencies. Like first of all, we know that everyone, whoever tried to mint the NFT, we have to refer to the oracle. So that's why we have to parameterize the oracle NFT into this Plutus NFT contracts. We know that this is a kind of simply logic flow. Like first of all, we want to mint the Plutus NFT. We want this minting to refer to some sort of oracle. So we must put this oracle into the parameters at the first place. And then we think about that, trace it backward. Like for this oracle NFT, I want to make sure that there's a possibly the single source of truth out there in the Cardano. Like when we call it the oracle NFT, it must be definitely unique. So in Cardano on-chain development, we have a simple trick about doing this, is that we know that is a very standard contract, is that there's a one-time minting policy. Like we can parameterize the UTXO into the kind of the parameters of the oracle NFT. And then whenever we try to mint it, we have to spend the input. Taking advantage of the characteristic of UTXO is that for whatever inputs they have, it is only possibly to be spent once. We know that for whatever NFT or tokens that we minted through this transaction, it can only be minted once. And then we could think about that after we have minted this NFT, we should have somewhere to lock it to prevent the data to be kind of changes. So that's why we need an oracle. That is a spending validator just to lock the oracle NFT. And then for whatever reasons that we want to update the information, there must be some solid reasons. So from our application, very simply, so whenever people try to mint the Plutus NFT, they have to add the count by 1. And that's the core logic of the applications. Since for the oracle, this is the end of everything, we don't have to further parameterizing anything. So we come into this first step of the contract kind of design after we have drafted some business logics that we want to plan. Is that we try to making sure that the parameters oops, it's not updated yet for this. Yep, never mind. So we could just update it from here. Is that for the Plutus NFT, we need the Oracle NFT to be parameterized. And then for the Oracle NFT, there's the UTXO to be parameterized, and then Oracle, there's no parameter needed. So we know that the first thing that we want to do is that the UTXO ref in the Oracle NFT. And then after this, we know the second layer is that the Oracle NFT policy ID is in the Plutus NFT. Let's conclude the very simple parameter tree for our applications. So why this is very important is that there are a lot of occasion in our application designs, we might run into the issues of circular parameters. Like, for example, if you want to include the Oracle address in the Oracle NFT, hypothetically, and then by the same time, we want to, let's say, include the Oracle NFT into the Oracle address. This is what we call the circular parameterizations. Like one script is parameterizing another script, and then another script is parameterizing back to the original script. So when we run into this circular dependency, it will make our application never be able to be compiled and then deployed into the real world, because we just cannot do the circular parameterizations. Because once you parameterize this one, it will change the overall policy ID of the entire script. And then with the change it policy, you will change the parameter here. And then you will change the parameter, the entire hash of this script, and then you will change what you want to parameterize here. So you cannot actually get the scripts ready for your production usage. So this is the entire ideas of why we want to do the parameters dependency tree, because this is serve as a purpose for us to have some sanity check before we try to put some script into the productions. So I just slightly stop here, see if there are any questions. Yep.
Good job on
So
the
from
circular dependencies. Yeah, we in the lesson about this, we have some notes about the single directional graph that we want to be able to make here, and that's really good to call that out.
Yep. So another reasons why we want to have this parameter dependency graph to be prepared at the time of architecture is also try to serve as a reference at the time of us try to deploy some dApps into the off-chain rims, because we want to calculate the policy one by one following this tree to make sure that our kind of off-chain softwares following the same patterns, and we know exactly what we want to do to get the actual scripts to use. Yep. So this is this step. So now we actually goes into how we could write the specification itself. So perhaps this is the most interesting part for most of the people, because I will argue whenever you want to design a Cardano dApps, 90% of the times and efforts is actually into trying to spec out what exactly you want to do with the validators. Once the specification has been out, it just takes you very, very minimal amount of times to actually implement the scripts, especially when you are familiar with the syntax about Aikens and the functional programming. So when we try to do the specification, there are two types of specifications that mostly, yeah, I would argue there's mostly these two types. There's a minting and there's the spending. So for whatever other purposes of the smart contract or validators, it's usually in the shape of minting. So I will just cover these two so you get the idea of what it looks like. So in our previous NFT example, there are actually two scripts that they're minting policy specifications. So one is the Oracle NFT, and another is the previous NFT. We notice that these two validators are used for guarding the minting and burning of some tokens. So that's why we call it as a minting policy. And this is a corresponding specifications. So for whatever minting policy we have, usually we want to determine two things. First is the parameters. Parameters usually we call it kind of necessary, kind of a key components or a share component for all scripts. So whenever you want to write that a minting policy, spending policy, or spending validator, or a withdrawal script, staking scripts, we all have these parameters. Like as we covered in the previous SLT, The parameters is what we usually call as kind of the hard-coded value in the scripts. Like you could put whatever hard-coded value into your scripts, and then once you put different value into it, the entire script hashes and then the script will change. So this is something that we could do for every single kind of scripts. And in minting policy, we have also just one more things to think about, which is the redeemer. So when we think about the redeemer, we have a kind of a metaphor into the web development realm. It's more like what is a payload uh, or the JSON that you attach with a post request. It is the information that you want to supply when you try to interact with the smart contracts or scripts. So usually for the redeemer, that's something that we cannot guard. Like the users could just input whatever redeemers that they want. It is usually helpful for us to try to route different application logics into different piece of codes to improve the efficiencies and etc. So when we think about the minting policy redeemers, we could easily to think about from a perspective of what actual user actions you want the users to perform, such that they could choose they want to mint it, or they could choose they want to burn it, and then you would perform different checks accordingly. So first of all, we know that this is a Oracle NFT. We go into the context is that we know this is a one-time minting policy. So we just check whether the parameter UTXO ref has been included in the inputs, such that there's only one time valid in the minting. And then for the burning, it's very simply that the current transaction has only negative value in the policy that we are burning. So you could notice that it comes to more of a habit about how you write these specifications. So far from my experience, there are two types of specification that you could write. Here we can see that there's a type that the description is more verbose, but less technical with less technical preciseness. Like I didn't describe exactly this is UTXO ref, for example, if you want to be more precise, but rather I just serve it as a kind of a more verbose kind of communication wise about how you want to perform these actions. So I think for most of the time when we try to write this specification, as long as there's no ambiguity left and there's usually the acceptable lines. But I would still suggest that when you starting out the specification processes, usually you just try to describe as much as you can. You want the script to do the how you want the script to perform the checking. So as long as you are not confusing yourself, then the next step you could goes into trying to try to describe it in a more precise way. So the second example is a little bit more complex, which is the actual business logic about the previous NFT. So you could see, oops, yeah, this is also incorrect example. I include the datum here. Never mind. So this is a more kind of complicated example because when we try to do the previous NFT maintain, this is actual business logic about what we are trying to do. So from here we can see that we same have the parameters. So from here I have parameterizing the Oracle NFT. So that I know that where exactly I try to locate the single source of truth for the applications. And the second thing I parameterize here is the collection name. Like this is a kind of the optional field, but but in a lot of different NFT projects in Cardano, usually you want to enforce it with the token names is including your project names. So for example, having the host key NFT, you want the token name to be included to have included the host key, for example, in the token name. So this is how this parameter to be used. And then same for the user action. You think about what exact action you want the users to perform. For tokens, usually for a lot of the time, there's just mint or burn. Or you could include different ways of minting a token into different redeemers. But this is also a relatively still simple examples. So we just have the mint and burn. So I will just have a very light touch here about the actual specification logics without going into further details until we meet 301.5. So from here, I only check whether there's the input containing the Oracle NFT. And then there's exactly one token minted with the correct token name, taking into account the collection NFT collection name and also the counts in the Oracle. So that's the minting logics of the previous NFT. The second type of the specification is indeed the spending validator. Yeah. So from here, from our example here, we got the Oracle validator as the spending validators, and there's only examples here for the spending scripts. So same as the minting validator, we have the parameters, and we also have the user actions, which is what we call the redeemers. And in the spending validator, we also have the datum. I think I haven't changed quite a lot of the wording from the last example, since the example was originally a more complicated example. I trimmed it down into a easier one just to deliver the message easier. Yeah, I take the wording from here. Yep. So from the spending validator specification, we want to also lay out what is the datum type. We know that for this example, the core business logic is the count, so that we can make sure that different previous NFT having different token name with the counts encoded into the previous NFT that we are minting. From here, there's the two other datums to serve some extra business logic. Is that for quite a lot of Cardano NFT projects, you actually want to charge a fee at the time of minting. So the datum also contains this information about what exactly is the price that we want to charge and where the price should go into. So for here, we have two mint NFT. So we have two actual kind of logic routes. First of all is to just perform the NFT minting. So we want to check there's only one input and output from the current address. If you're doing so, you could very easily to identify that there's the value, the input and output value are exactly the same, such that the NFT is not going out from the validators. And then from here, I will also check that whether the count is +1 and the fee is paid. But one thing is there's actual one hidden logics from here is that you can see that from this Oracle specification, I didn't enforce what exactly is the Oracle NFT. Is there anyone here know why I didn't do that? Like why I didn't put the Oracle NFT into parameters here? As a thinking exercise.
I'm just listening in the background, but I guess because you cannot have the address as parameter then to the Oracle NFT.
Yeah, that's a good attempt, but actually when we try to do it, like if we parameterize the Oracle NFT here, and then we go back to the parameter tree, we probably just add this into into here. So when we checked about this parameterized tree, we didn't run into circular dependency. It's still in the one direction. Like we have this Oracle NFT we put into the two other scripts, which looks fine. So this, yeah, sometimes it might be the issue, but for the script we have right now, it is not the actual issues. But for sure, we could do that because we know that we didn't run into parameterized circular dependency issues. But how can, or I put it in this way, if I do not include the Oracle NFT into the parameters, how I know that I'm actually having the Oracle NFT, the correct policy in this Oracle address? This is
You
a
put it into the datum.
datum, but I don't have anything here. Like I also don't have Oracle NFT here. And I could tell that this application is working perfectly fine, still without the Oracle NFT information included in parameter and datum.
Can you go back to the dependency tree?
Okay. This is a dependency tree. And I didn't do that. Or rephrase the question a little bit. Why I have the confidence that the application is working fine, even without I didn't put any Oracle NFT information here. This is perhaps a little bit more advanced question. Any more attempts?
Yeah, we are using the Oracle as a because it holds the counter for the Bluetooth NFT.
Yep.
And you only then, yeah, it's enough to just have the Oracle NFT policy ID in the Bluetooth NFT to know where the correct data is coming from.
Yep. Yep. That's correct. That's
And this way
that's
you
the
can
correct answer.
and this way you can use the Oracle validator for more for different Oracle NFTs.
Yeah. Yeah, that's actually the perfect answer. You're very spot on. Is that for this Oracle address, it's actually possible to serve different NFT project in the same addresses if we didn't provide the Oracle NFT into here. Because it's at the end of the day, it's only the Plutus NFT contract that cares about where the Oracle comes from. And when we have been successfully locked this NFT into this Oracle, we know that only by this line of check, the output value, the yeah, this yeah, I should have typed it better. So we know that with only this line of check, which is the output value is always equals to input value, we could ensure that the NFT is never flowing outside of the validators. So we could ensure that so for whatever value that we are locking in these scripts is never flowing out until we stop the applications. So the implication is that in this contract, we don't care about what exactly is the value that is locking. But when we use the Plutus NFT scripts, this is the only scripts that we care about where the Oracle NFT is about. So it leads to two further discussion about designing applications. So first of all is what are the actual user actions and how we should set it up. So since we have touched on this part of the answer, maybe I just reverse the order to it a little bit. Is that for the setup of the Plutus NFT contracts, there have to be some manual careful steps before we can make the application functioning well. So we know that this Oracle NFT, we could just mint it. We could just mint it and then float the value anywhere in the Cardano ecosystem or the blockchain. We could just send it to your wallet, to my wallet, or to any smart contracts. And then we know that we could mitigate it by some careful manual operations. First of all, to make these steps to be working, we have to make sure that the Oracle NFT has just minted with quantity of 1, so that we could call it an actual NFT. And since it is a one-time minting policy, if we have minted it for the quantity of 1 at the time of the minting, we could be 100% confident that it is the actual NFT in the Cardano blockchain. After we have minted it, we have to send the Oracle NFT into the Oracle, and then with the initialized count to be 0 or 1, just whatever is the starting counter that you want it to be. And then there are also some careful configuration about the price that to be charging, and then the fee address that's controlled by a normal private key, which is not scripts, to making sure that the money is not permanently locked when you are charging the fee. So from here, we also put down what are the validation of each steps. First of all, when we try to mint the Oracle NFT, there's a script number 1 and action number 1. So I call it, for simplicity, I just call it 1.1, with a number 1 scripts first redeemer. There's a validation that we want to go through when we maintain the Oracle. And then when we try to send the Oracle NFT into the Oracle validators, there's no validation, because we are just passing value from one private key or public key address into a contract. So usually for a lot of the times, whenever we want our dApps to be working, and when the dApps become a little bit complex, you have to do some sort of setup. And this is what we call the application setup documentations. So when you have completed the implementation of your scripts and pass it to the auditor will also ask you about how you could set this up, to making sure that there's no steps or there's no vulnerability at the time of setup if you're following the steps correctly. So this is the first part of it. And then another part is about another part of the question is that why I could be assured that I didn't put any Oracle NFT information here, the application is still performing fine, is that we could have some sense checking by combining the validation with the actual user step that we wanted to perform. So for example, in this application, we have the single application logics that we want people to do, which is to minting the NFT. And then whenever we mint the NFT, there's not only one script that is checking. First of all, we know that this NFT is going to be minting. So 3.1 is definitely going through validation here. But at the same time, we also want the Oracle datum to be updating, the count to be updating. There's a second script's first actions. So we could combine the two together. So we know that minting an NFT have to go through the checking of 2 different scripts. So why this step is important is that when you take a look into the either 2.1 or 3.1's logic, there's never complete. Like there's only one input with Oracle NFT, and then there's only one token minted. And here I check the datum, but yeah, if you take a look into any isolated items, for example, just these 2 lines or just these 4 lines, they are not the everything in isolation. They are not everything that we want to check. But why this user action documentation is important is that once we have written the validation that we want, we could take a look into what's actually happening when we combine the two checks together. So when we combine the two checks together, these are the actual checks that's happening together at the time of people minting NFT. So two important implications here. First is that when you combine the validations logic together and you check it yourself in a holistic view, you can have a more full picture about what's actually checking in the same transaction to making sure that you didn't missing everything out. So going back to my original questions is that I didn't have the Oracle NFT information here, but why I'm assured that the application is performing fine is that when we combine the two things, we know that from the previous NFT contract, we are actually having the check about the Oracle NFT. And we know that this is included in the check here. And then we looking back into here is that only one input and output from the current addresses. We know that this input and output is equals to this input. There's only one input, right? They're actually the same inputs that we are checking. And when we try to combine the different logics together, we could see the power of kind of having some smart contract logics that are delegated into different scripts. However, we're still in the same transaction so that everything could be checked together. So same like the count is updating. So the datum checks we have delegated into the spending validator. The output value check we have also delegated into the spending validators. Fee also spending validators, and then token name and mintings kind of logics we have delegated into the previous NFT contracts. So this is the first implication about having this user action documentation, is that you could try to combine every single check from different scripts together to take a look into whether there is some logics that you're missing. And then second part of the implication is also some of the common mistakes by some early or new Cardano developers, is that usually it's very tempting for us to include different duplicated checks into different scripts. So for example, in here, I could actually perform, let's say, all these check, all this spending validator check. I could also include them into the minting policy, which is perfectly fine. Even I implement the previous NFT contract like this, and then implement the spending check like this, I could still do the same thing. Like probably the previous NFT is still guarded from minting incorrectly. But the problem is this: if I having these force line also checking here, and when we combine that together, the entire check will look like this. And we know that in Cardano blockchain, every step of script validation is very expensive. So if you try to check the two identical logics in two different scripts, it will waste a lot of we call it execution units, and aka the fee, the Lovelace fee or ADA fee charged by your smart contract transaction will become a lot more expensive. So just by combining the user's actions and the validation logics together in this user action documentation, you could possibly remove the duplicated logics. Like for example, whenever you have a situation that you have identified the datum has been checked twice, then what you could do is like, for example, this is the case. You could then decide whether you can remove this line from the previous NFT or you remove this line from the spending validator, which are perfectly same and perfectly fine as well. So this is the second implication of having the user action documentation, is to try to help you to identify, is there any duplicated check from your applications. So I think here's we have the small conclusion about how we could, or what are the usual consideration when we want to architect a Cardano dApps. And yeah, I will just pause a bit here before we move into the blueprint part, or maybe we can have some slight discussion from here. I didn't really gone through very detailed about the thinking process about how to decide the specification for samples. Usually it takes quite a lot of time. But in any of the Cardano dApp development, most of the time you want to cover all of these elements before you write any single lines of code. Yeah, Newman.
Yeah, hey, and thanks for doing this. Is this a common practice and are there sort of live examples of these specifications out there?
I have to find. Probably
But
I have quite a lot
I mean,
of,
I think it's
yeah.
no, I mean, not to just I'm wondering if it's an emergent sort of thing, and I can understand, especially with the fees and to understand the logic so that you can build out a lean and then not the looping. I can see where that could happen if you've got all these things flying around in an application as they get more complex, even in simple examples just like this. But I'm curious about what it might look like in a bigger thing. For instance, our Asteria game project. I haven't seen this and seen it said like this. They do have a design document that sort of approaches this,
Mm,
but this is wonderful. So I'm wondering if it's a
yeah.
format that's out there in the world.
I cannot say that this is kind of a formal format about how to do the specifications, but this is like more like my preference of doing it. Like there are a lot of different, certainly there are a lot of different formats out there in the Cardano ecosystem about how you could do the specification for samples. But this is a kind of a more lightweighted format after several iteration by my personal experience required by, for example, auditors. I know that they're checking out these things actually. So for other depths I know, it's possibly that having everything combined into one documentation, like work documentations, like laying out every single details about how the scripts is assumed to be performing. But when I try to break it down and put it in a simpler format, this is more or less like my conclusion. What are the necessary items of yeah, at the time when you try to do or design a applications. After all, this set of architecture documents is more about how to communicate your application, your decentralized application to other developers. Perhaps it's a community that's looking into your dApps, or the auditors that's trying to give a assurance about whether your dApps having any potential vulnerabilities or how it works. But I could tell that certainly this is more like my preferred way of doing this the thing. Probably that's a core part of having the technical documentation about decentralized application in Cardano. But certainly, if you ask whether there something extras that we could do, it's certainly yes. Like I've trimmed it out into these core components. Like some other things that we could also do is most of the time when it is a more complex applications, the auditors or others might ask you to produce some sort of diagram about how different scripts are interacting with each other's, and then how the value flow into different validators. But for most of the time, if you're having these things described precisely, those are just the byproduct of these core sets of documents. Like you could probably just draw the document by draw the diagram by looking into these different sets of specifications or descriptions or documentations. So yeah, but
Love
yeah,
it. Thank
I'm
you,
also
man.
curious. I'm also
Yep.
curious if you find other references. I also want you to take a look
I've got
so that I can
I just put it on my to-do. I'm gonna definitely look around for just those terms like specification, design, documentation, audit. Like what? Yeah, like this is definitely in my wheelhouse. So thank you for giving this presentation. Um, I'm curious.
Yep. Any other
I mean,
thoughts
Adrian.
and
Yeah. Yeah, keep going. Yeah, thank you.
Yep, I just have a very small part left for the day, which is the blueprint. So it's all good. Okay. If there's no further questions or comment from here, we move into how the scripts actually looks like. So after the specification, we can just think back our lessons. The implementation itself is rather straightforward, let's say. So when, for example, when we look into here, we just implement it according to here. Just there are two redeemers. Then when there's burn, we check that it's only burning the current policies. When it's maintain, we just try to make sure that in the input, we can find the UTXO. So when you have these core logics laid out already, usually it's relatively easy for you to implement everything. Even with the more complicated case, like here, same burn is the same, only burning. And the maintain, we check that there is a input with policies here, and then we pattern match into a single item list. And then we get the inline datum, we check the count, we make sure that the collection name is taken into account into the SS name, and then we put the count, convert the integer into bytes, and then put it into asset name also. Then we check that it's only minted once. So usually when we have the specification written out, it's rather simple to actual implementations. So after we have written these three scripts and then we hit the Aiken build, we come into the format of having this blueprint. So this is the second part of today's Aiken PBL, and probably there's a kind of more like a capstone about the Aiken PBL so far. Is that for all the lessons that we have gone through, everything that we have gone through, writing specification, writing codes, building unit testing, what we actually care is to come up with this previous.json. Like for this previous.json, it contains quite a lot of information. So we collapse it into different parts. So you can see that there are three different parts in a previous.json. So first of all, there's a Gimbalabs part, which is like a basic description about the current project. Is a title, previous NFT, description, version, what's the previous version, what's the compiler version, what's the license. There's like the basic information about your project. And then here is the core part of everything. Here's the validators. This indeed included your so far all the logics that you have implemented is condensed into this compile code. All these things, very long string, are the kind of the condensed material about the lambda calculus about how you execute your Aiken codes. If the big function, the big Boolean function is actually just contained into this string. And then when you trying to do something in the off-chain game to interact with the validators, you have to interact with this compile code mostly. And then from here, you can also see that this oracle, we have the spent methods or the script purposes if we want to check. And the datum format is corresponding to this format, and the redeemer format is corresponding to this format. And when we try to check this, like here, we translate this into slash. Is it? Or it's not? Yeah. We could find that under the definition part, the third part of the blueprint, we could find out exactly how it looks like. So this is a in the Aiken code, we call this Oracle datum. And then this is indeed any of these items. And if this item is only one items, so we know that the Oracle datum only having one potential format, which is a constructor with 0 index, and having the first field as integer, second field as integer, and the third field as a address. And then we know that this is in a recursive structure, such that we could just trace down the definition one by one. So address is representing by this format, and then we could just trace it down as we want. So in short, in this blueprint, it gives you the actual script informations. It gives you the definition of what to include in datum, the shape of the redeemers, etc. And then it helps you to also pass it down into when you implement the script, you have specified the spending logic. You're specifying there's a else logic. And then you have specified, for example, Oracle NFT, there's a mint logic, and there's also the else logic. Yeah, Adrian.
Do you know if is there a way to get rid of the else validator? Because mostly it's just a fail.
Yeah.
So can I get rid of that? Maybe with configuration or something?
I don't know. For a lot of the time, I just ignore it. But if you take a look into the compile code, it's actually giving you the identical one. Like it's a more of a verbal definition about what exactly included in your scripts. Yeah. Yep. So I continue from here. So this is an actual output of everything that you have been doing so far, and then this compile code is everything that you need to start building in the off-chain realm. Since this Aiken PBL, I didn't go very deep into the off-chain paradigm. But one thing that you have to be making sure is that this compile code isn't something that we could just use out of the box. So why I'm mentioning this is that, so for example, some scripts like Oracle NFT, they're indeed the parameters. So for this compile code, it's indeed the compile code before applying parameters. So even like the Oracle spending validator is without parameters, you still have to process it like applying no parameters into the compile code before you actually are using it for the off-chain code. So there's something that I would like to highlight. So I just slightly stop here. Any questions from the floor before I do some kind of extra coverage on the blueprint? Oh, good. Is that so? We know that we have this Plutus.json, and there's containing a lot of information. However, is we know that we still have to do quite a lot of things to make this compile code to be working. Like we have to making sure that this is after applying parameters, and then we have to making sure that we have implemented the data structure correctly. So here's come to the advertisement part, is that I slightly having a spoiler last week, is that in CDAN we have a tool called Cardano bar. There's only one feature is currently implemented. I just expedited the implementation of these features because I know I'm going to talk about blueprint in today. So if you have installed it, and we have a TypeScript file, and then we have this pass the blueprint to TypeScript. And then we choose the products.json that we want to pass. And what it could do is just to look through your blueprint to help you to extract all the compile codes, put it into the correct namespace that you are originally defining it, and having some type definition about all the datums, redeemer, by just the menu process of recursively looking through everything. So here gives you the correct shape of everything. Like for example, integer is defined in this shape, pub key address is defined in this shape, script address defined in this shape. Because the addresses, it could be either pub key address or script address, etc. Like even for the redeemer, we know that what exactly are the constructor formats. And something like for example, this mint polarity we have implemented twice, once in the previous NFT, once in the Oracle NFT. It will just compile twice, but never mind, just we know that they are identical, so just delete it once. And we could, with this blueprint objects, we could just directly use everything out of the box. Like for example, Oracle spend blueprint. In the constructor, we don't have to apply any param. After we have getting this blueprint object, what we could do is like just by dot address, we could get the address directly. Dot hash, we get the script hash directly. Dot cball, we got the apply after post-processing compile code to in our dep directly. So this is one thing that I would like to mention, because once after you get the process.json and you want to manipulate it for the off-chain rail, there's still quite a lot of things to do. But if you want to just quickly iterate about what you have just built in the Aiken PBL or in the Aiken so far, the easiest way is go for TypeScript. And then installing the extension and then having this auto compilation, and then you could compile into all the mesh type. That's help you to directly start developing in the off-chain well. So I think with this also mentioned, we could eventually conclude the Aiken PBL in this iteration. And I hope every one of you at least learned something throughout the past 3 months. And yeah.
What
That's
a
awesome.
flourish to finish with.
Yeah. I mean, I looked away for a split second. I mean, you made a magic trick. Do it again. Do it again. I mean, it's like someone,
This
like
one.
like an uncle pulled a coin from behind my ear. What did you do?
Yeah.
So you just,
Just
okay,
You've
that's
got the
it.
extension set up and you've got the key command for it up there at the top.
Yep, just get the extension installed, and then you just try to do
Parse
this.
blueprint to TypeScript. Okay.
Yeah. I will
Select
also
the,
try to select the process.json that you want to pass.
grab the JSON.
Yeah.
Click on open. And then
Yep.
your uncle has cut off your thumb. What in the world? Oh my God. I don't know if you guys know that trick with the, yeah.
Yeah,
It
this
seems
is
like a
an
magic
internet
trick. This
new
is
feature.
incredible. This is incredible. Wow. Okay, thank you.
Yeah, please do try it. Let me know if there are any bugs or
Oh, actually,
anything.
yeah, I can try it right now.
Yep. But I could tell you that this could save many hours about about the transition into the off-chain. At least when you try to quickly test through it, you may not choose TypeScript as a test set initially. At the end of the day, like if you just want to quickly iterate about the dApps and maybe perhaps with the YACs, this
Make a
I would
little
say is
prototype.
arguably
Yeah, it's like a quick way to
the
just fire
fastest.
up some transactions, show people what you've got. This is amazing.
Yep. For
Nelson,
this
what do you think?
constant,
Oh, sorry.
you have to configure. For this constant, we have to configure. Like this is getting from the blueprint, so it's fine. Network ID you would like to configure, making sure the address is in the correct format. And for this state key hash, is that for every spending validator address,
Beautiful.
you have the staking part. You could include that also. Like
That's
whether this is a scripts, then you could get the correct address and correct hash.
and so
Yeah.
you don't have to think about that part, right? You just throw it right there and you're done.
Yeah. You just have to configure these 3 lines.
That's amazing. Nelson, what are you thinking?
Hey guys. Yeah, maybe it's more of a question to Adrian or Hinton if you have compiled the Plutus file using Plutus TX. But yeah, Adrian, I tried this with the blueprint that you generated using Plutus TX. It doesn't work. So I'm just thinking if you guys have ever compared the blueprints that Aiken generate and Plutus TX generate.
I see, I see. Yeah, maybe there's I only built it with the Aiken part. Maybe I could specify it for now. This is working for the Aiken blueprint.
Yeah,
But that's
that's
a good feedback.
very likely that the Bluetooth TX one is not working as they are not straightly following the CIP. They have some
I
small,
see, I see.
but maybe
Yep.
in the newer Bluetooth TX versions it would work.
Interesting. I'm not aware of that also. Yep.
Vincent, I want to give you a big shout out for democratizing the audit process as well, right? Just the way you're going through that. I think this term audit feels like a black box to a lot of people, and it's hard to understand what it is, and therefore it's hard to put a value on it. But your demonstration of how it, you know, there's these like there's these shared concerns that are mutually reinforcing, right? We want cost-effective validators. Well, to be cost effective, you also need simplicity, right? The minimal number of checks. But the less you're trying to do, the easier it is to audit too, right? It's more secure. So that push to kind of demystify and say, like, look, now that we're building in Plutus on this public ledger, actually simple code is very powerful. And I think you did a really good job getting this idea across. And maybe we can help more people just understand that auditing is a straightforward process.
Yeah.
It's detail oriented and you have to take it seriously, but it's a learnable skill. It's something that more of us can help to do.
Yep. As long as you got those documentation precisely correct, it 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 can be just be more verbal and yeah, like descriptive, not exactly to the everything to the technical terms. Still, you can have a very precise understanding about what this step is better to behave. Like from there, we could do a lot of do a lot of things from there. Like like checking whether each line is actually implemented correctly.
Right.
And yeah,
But once you answer the question, right, like, hey, can this token only be minted to this address? Yes or no, right? Like, and once that is confirmed, there's nothing more to say about it.
yep. Especially when you try to having the user action documentation combine the checks together, it's just as crystal clear about what this transaction is better to behave. Like there's no deviation actually. But still, there are a lot of logical thinking behind the scene. Like the hack, quite a lot of time is creative. So you have to think about very carefully each step, how to link with each other's. But yeah, this is a
Uh, I might eat
simplest
my words when
demonstration.
we, yeah, I might eat my words when we try to audit Adrian's work on Andamio. We'll see if we can make those things simple enough. But they're
Yeah,
straightforward, right?
yeah,
Cool. Hey, well, thanks. It's exciting to wrap Aiken PBL kind of officially. We'll get this video up there. The content will continue to evolve. And I know Harsha, Newman, and Adrian are all working through the course, earning those credentials. So next steps for Gimbalabs is to make sure those credentials actually unlock access to something. So we're excited to get some projects in motion and give people a chance to flex their new muscles. And then on the education side, I know that Sedan Labs has a more general Cardano dev course in mind. So Hinson, for us, I think next steps is to talk about if that's something that we want to put on the calendar.
Yeah, sure. Yeah, hopes everyone enjoying this series.
Yeah, it's exciting. We could talk about that on the beach in a couple of weeks.
Yep, sure.
Anybody else got other questions before we break? All right, thanks. These sessions will continue. We'll have another Aiken PBL next week, or sorry, live coding session next week. But we're going to go back to the wide open agenda. So bring your questions, bring your projects. We can talk about anything. We will prioritize looking at Aiken related projects. But obviously the agenda is open. So bring your questions if you've got them. We'll take a break the week after that, and then we'll go into May. So looking forward to what's next, everybody. Be in touch. Thank you.
Thank you.
Have a good one. See you soon.
Yeah, see
Bye.
you soon.